All right, guys, so we're back for our second lesson in Unit 2, where we are going to be continuing with derivatives. So we learned the formal definition of a derivative last time, where you had to use the limit to evaluate the derivative. But we need to remember that the derivative here, we're looking at this, is that it represents the slope of the tangent line to a curve at a point, right? So if I take any of these points and I draw a line that's tangent to it, meaning it hits it only at that point, I can use that to evaluate to get the derivative at that point. So let's just use a graph to kind of talk about this. So here it says x equals -7. So when x equals -7, 1, 2, 3, 4, 5, 6, 7, I'm talking about this point here, right? So if I get a line, you guys get to bear with me while I figure this thing out. So if I get a line and draw a tangent line to that point, it's going to be, I don't know, something like that, right? Okay. It just hits it at one point. Of course, it's an approximation because I just drew it by my hand. You can get a ruler and do it right next to it, right? So if we look at this pink line, which I know is hard to see, let me zoom in more. What could I approximate that slope to be, right? I could probably keep drawing this here out so it'd be easier to approximate it, right? So something like that. So the slope of that line maybe looks like it's, just extend it out, something like that. So the slope there might be, it's a positive slope, right? And maybe up 1, 2, 3, 4 over 1. So it's around 4. So what I could put here in my box is that f prime of -7, and then I'm going to use my squigglies, is about 4, right? It's approximately 4, I'm estimating. Okay, so is the function increasing, decreasing, or at a relative max or relative min at x equals 7? So hopefully you can see at x equals 7, it's going up, so it's increasing, right? I'm just going to write increasing. And then what's the equation of the tangent line at that point? So now you have to remember how to write a linear equation. So you can use slope-intercept form, but that's usually not the easiest. The easiest is point-slope form. So we have to remember what point slope is, right? So here, let me find a new slide. I'm just going to share a tab where it comes up. So if you don't remember, here is what point slope is. So you need to write this down. Y minus y1 equals mx minus x1. So the reason point slope is easier because all you need is the slope of the line, and then you just need one point, and you plug in the x coordinate for the x and the y coordinate for the y, right? It's a lot easier to figure out than slope intercept. So write that down if you need it. I'm going to go back to the tab. So if I had to write an equation for this tangent line, I'm estimating the slope is 4, and I have the point -7. So this is -7, -3, right? So I could write my equation of the line in point slope form as y minus y1. Well, y1 is -3, so that's y plus 3. Because really, I'm doing this, right? But y minus -3 is y plus 3. So I'm going to write like that. Equals the slope. The slope we said is 4. And then it's x minus x1. Well, what's x1? x1 is -7. So x minus -7 becomes x plus 7. So that is the equation of the tangent line at this point when x equals 7. Okay, so let's try a couple more. So let's look at -6. So if I look at -6, get another line here. Let's make it green. Here's -6. So if I draw a tangent through that point, what would that look like, right? It's gonna like be going above it a little bit and just hitting at one point. Something, oops, that one's bad. Let's undo that. I can figure out undo. Let's do it again. Something maybe more like this. Okay. I'm calling it. That's close enough for me. Okay. So what is my estimation of the derivative? So what do I think the slope at that point is? So f prime of -6 equals, so I'm going to use that notation here, and that's not going to be equals, or is approximately. I'm going to do this because I can't type the squiggly lines. Actually, maybe I can do this one. There we go. It's approximately what? So if I have to look at the slope, it's still positive, and maybe it's like a positive 1, 2, 3, 3/2, maybe, right? If that line connected up, I'm just using the grids to count. So it's a positive 3/2. So let's write that. And depending on how exact your drawing is, this is going to be different, right? And then now, is it increasing, decreasing, relative min or max? It's still increasing there, right? So I'm going to write increasing. What's our equation of the line? Well, it's y minus y1, and y1 here is 0. Y minus 0 equals the slope we're estimating is positive 3/2, and then x minus, what's x? X is -6, so x minus -6 becomes +6. I'm writing that down. And guess what? I don't need to write y minus 0. So here's the equation of the line. Y equals 3/2 times x plus 6. The equation of the tangent line at the point x equals -6. Okay, let's skip around. Let's do, actually, we're going to do -4 because -4 is a good one. So I'm going to get my line tool back out. Let's do yellow this time. Here's x equals -4. What is the tangent line going to look at x equals -4? It's going to look just like that. It's a horizontal line, right? It's flat. So who remembers what the slope of a horizontal line is? Hopefully everyone remembers. If the line is flat, then we are saying that f prime of -4, this one equals 0 for sure. It's flat. It's not an approximation right here. So it's 0. Why? Because this is a relative max, right? At this point in the graph, this is a relative maximum, meaning it's the highest point right here. It's not the absolute maximum, it's just a relative one. So if there's a relative max, and what would the equation of that line be? Well, what's the equation of a horizontal line? What would that be? Take a second and think. Hopefully you know it's just y equals 2, right? Because that's where it crosses right at 2. So the equation of that line is y equals 2. So there we go. So what I'm noticing is that if the graph is increasing, the derivative is positive. Well, that makes sense because the derivative is the slope of the tangent line. If the slope's positive, the derivative is positive. If we're at a relative max, the slope is a horizontal line. Therefore, the derivative is equal to 0. Let's try one that's a relative min. What about at x equals 1? So let's get my line here. At x equals 1, same thing, right? It's another slope of 0. So I'm just going to skip over. I'm going to skip some and go to x equals 1 right here. And that is f prime of 1 is equal to 0. Why? Because at that point, the function has a relative minimum. And the equation of that line there is y equals 1, 2, 3, 4. Y equals -4, right? Equation of the line. Okay, so we're going to move on to page. Let me see how far I'm going to go with you. This is a long one. So we're going to skip over to the next one. So you could keep doing these for these points. But the idea being that at each point when you have a graph, you're drawing a tangent line, right? So any point, you're going to draw a tangent line. So how can I draw a line that's next to this that only hits that point at one spot, right? Then once you draw it, you're going to approximate the slope from it. So this one is a negative slope, right? So you could approximate the slope here as down 1, 2, 3, down 1. So you'd have to figure out where it crosses. If it crosses here, it's down 1, 2, 3, 4 over 1, right? So you could maybe say the slope is -4. right? But that's what you're doing is you're drawing this tangent line and actually using the grids to count, okay? And when the line is increasing, the function is increasing, the slope is positive, the derivative is positive. If the slope of the tangent line is decreasing, then the derivative is going to be negative, right? And if you have a relative min or max, you should see that the derivative is 0. So let's keep going on. So based on what we observed in the table, what inferences can we make about the value of a derivative? Well, hopefully you're noticing that if the derivative is 0, less than 0, that's because the function is decreasing. So let's write that. Type in here. If the function is decreasing, then let's just say at x equals c, then f prime of c, or the derivative of c, is less than 0, right? It's negative. And the opposite is true. If the function is increasing at x equals c, then the derivative at c is greater than 0. It's positive, right? Case there. All right, and then we also notice is that if the function has a relative max or min at x equals c, then the derivative at c is 0, right? Because it's flat. The tangent line there is a horizontal line. Another way you could write this is that if the function changes from increasing, oops, let me spell that right, to decreasing, or from decreasing to increasing, right, the other way around, then f prime of c, if you put here at x equals c, then f prime of c is 0, which is the same as saying there's a relative min or max there. If it changes from going up to going down or going down to going up, it's going to have the tangent line is going to be a horizontal line, which means the slope is 0. All right. So let's look at this. Let's keep going down. Numerically, the value of a derivative at a point can be estimated by finding the slope of a secant line passing through 2 points on the graph on either side of the point for which the derivative is being estimated, which is what we did on our notes on 2.1, right? We had c and then f and then c plus change in x, and we found the limit between those 2 points because we're trying to make that interval really small. So let's say we're given this table here. So we're going to use the table now to estimate the derivative. So how would I estimate the derivative at x equals 0? Well, I'm going to try to make an interval where 0 is within that interval, right? And because I only have the table, I have to use what I'm given. I'm going to have to use 1 point above and 1 point below. So I'm going to use the points x equals 1 and x equals -3 to find the derivative at 0. So what does that mean? I'm going to use the slope formula, right? So that means, see if I can type this in here. Remember this formula, m equals, and then y2 minus y1 over x2 minus x1, right? I can't make whoops, y1. I can't make them smaller. I don't think I can. It's an option. Let's see. Yeah, I can't make it subscript, but you guys get the idea. That's the slope formula, right? So if I'm going to estimate the derivative, I'm going to pick a point where 0 is within it. So I'm going to use this point x equals 1, and I'm going to use this point x equals -3. So if I'm plugging that in, I'll use my pen here. My slope would be, well, my y2 is going to be the point above it. So -3 minus y1 is going to be 2 over x2 is going to be 1 minus x1 is going to be -3. So I am using this point as my point number 2, right? And this point as my point number 1. So 0 is within that interval. And so now when I do my math, my arithmetic, -3 minus 2 is -5 over 1 minus -3 is just 4. So my estimation of the derivative is going to be -5 over 4. I'm estimating the slope at that point on the curve of the slope of the tangent line is at x equals 0 is negative 5/4. So is the function increasing, decreasing, relative min, or relative max, right? How am I going to know that? Well, the slope's negative, and I can see what's happening at 0, right? It's going from -3 to 1 to 2. So it's going, I'm sorry, I'm going the wrong way. If we're starting out, it's going from 2 to 1 to -3. So it's going down. So it's decreasing, which matches my slope, right? It's negative. So what's my equation of the tangent line here? Well, we're going to use point slope again. So y minus, well, what's my y1? What can I use for y1? I can pick either of these. I'm going to pick 0, 1. I'm going to pick the point it's at. Sorry. So 0, 1. So it's y minus, y1 is 1, equals my slope I'm estimating is -5/4 times x minus x1, and that's 0. So there's my equation of the tangent line at x equals 0 for the slope. All right, we're going to skip down to number 4. So for number 4, I'm going to do the same thing, right? I'm going to keep my interval where my top number is 6, -7, and my top point is 6, -7, and my bottom point is 1, -3. So if I'm finding the slope here, skipping down to 4, okay, y2 minus y1, that's going to be -7 minus -3. -7 minus -3 over x2 minus x1. x2 is 6, x1 is 1, so over 6 minus 1. This comes out to -7 minus -3, same as adding the opposite, is -4, right? And then 6 minus 1 is 5. So there's what I think the slope is. What's happening here? We're going from -3 to 0 to 7. So is that increasing or decreasing? -3 to 0 to 7. Well, it's going down according to this, right? If I look at the slope, the overall slope is decreasing. And then now I'm going to make my equation of the tangent line here. Y minus, well, what was the y value? 0, x is 4. So y minus 0 equals the slope, -4/5, x minus 4, right? And because I don't need to take away 0, I could take this off. So I'm just going to leave it there for now. Okay, so hopefully you're seeing how you can do that with a table as well. So instead of drawing the tangent line on the graph and counting the grids, you're creating an interval by choosing one point above that and then one point below that. So you can find the slope using that slope formula. Okay, last page. No, this is long. So the graph of a function g of x is pictured to the right. Identify the following characteristics about the derivative of a g prime of x. Give a reason for your answers. So they're asking first, where are the intervals where the derivative is less than 0? So where is the derivative less than 0? So if I come back up to what I wrote here, the derivative is less than 0, so this first line, when the function is decreasing. So we need to find all of the parts where the function is decreasing. So where are the intervals where this function is decreasing? Well, it's decreasing between -4 and -2, right? You can see it's going down. So let's see, how am I going to write this? I'm just going to use, I'll use a text box. G prime of x is less than 0 when the function is decreasing. This is true for the intervals -4 to -2, right? From -4 to -2. And then where else is it decreasing? After 1. So from 1 to infinity, it's also going down. And 1, 2, and I'm just going to write infinity like this because I can't type that symbol in. Okay, so I know if I had to figure out where the derivative is negative, it's where the function is decreasing. Okay, so now if I have to find where the function is increasing, it's going to be the opposite of that, right? So g prime of x is greater than 0 when the function is increasing. This is true for the intervals. All right, so it's positive, it's increasing from negative infinity to -4. So I'm just write negative infinity to -4. And it's also increasing from -2 to 1. -2 to 1. Okay. Okay. Well, where are the values of x where g prime of x is 0? Where is the derivative 0? Well, if I come back up to the rules I wrote up here, what we notice, the patterns, the derivative is 0 when there's a relative min or a relative max. So when that tangent line is going to be a horizontal line. So where are my relative mins or relative max? So let's write g prime of x equals 0 when there are relative mins or maxes. So this occurs on our graph at x equals -4 and x equals -2 and x equals 1, right? Those are the three places that the graph turns around and has a relative min and a relative max. Okay, one more thing we're going to go over. I know these videos are getting long. So the last thing we have to remember is a definition of a normal line. So here's this graph of this function that's right here. And it says to draw a tangent line to the graph of f of x at x equals 1. Okay, so let me get out my little line. So at x equals 1, it's right here, right? Here's the point. I need my pen first. Here's the point. Okay, now we have to draw a tangent line. So it's going to be a little bit above it. I'm going to try to do my best here. Something like that. Maybe. Where's my estimate? Okay, so what is the value of f prime of 1? Well, f prime of 1 is going to be whatever that slope is of that tangent line I just drew. So if I look at that, my slope is maybe down 1, down 2, over 1. It's a little bit more than 2 when I'm looking at it. I'm just going to estimate that it's around -2. It's a little bit bigger, right? But I'm going to call it that. Okay, so what's the equation of the line of the, what is the equation of the tangent line to the graph at f of x equals, when x equals 1? Sorry, I'm blurring all my words together today. I'm making lots of videos. So this is exactly what we did before. Point slope, y minus y1 is going to be, well, what's the y1 here? The y1 is 2. The y value is 2. Equals, our slope we're approximating is -2 times x. And what's the x value of that point? 1. X minus 1. So there's the equation of the tangent line at x equals 1. And sometimes you'll be asked to find the equation of the normal line. So all you have to remember is what a normal line is. So a normal line, let me get the pink, is simply the line that is perpendicular to the tangent line, right? So this point right here, this pink line, is the normal line because it's tangent. So this normal line, because it is tangent to this. Because, oh, excuse me, guys, here's a tangent line. This is a normal line because it's perpendicular to the tangent line. And I'm going to write that because my words are all messed up today. Normal line. It's perpendicular to the tangent line. So hopefully you remember your rules about perpendicular lines. Can you find the equation to a perpendicular line? Well, remember it has the slope of a perpendicular line is just the negative inverse. It's the rule you have to remember. Remember, if lines are parallel, they have the same slope. And if lines are perpendicular, their slopes are the inverse and an opposite sign. So what do I mean by that? Is if we said the slope of this line is -2, so here, slope of tangent line equals -2, then the slope of the normal line has to be the negative. So the negative of the negative is positive, and then the inverse is 1 over 2. And the slope of the normal line is positive 1 over 2. So if I have to write the equation for that, that's going to be y minus, all the other things are the same, y minus 2 equals, oops, and then it's still x minus 1. The only thing that changes is my slope. And so now my slope isn't negative 2, it's positive 1/2, right? So that's the only thing that changed. Okay, that's just to help you out when you get to problems like that, remembering what a normal line is. Okay, the rest of this packet is for you to practice finding derivatives from graphs. Until next time, double sorries for the long video.